Let's look at some problems from 6.4. We'll try to give you some help here. And I'm going to work these in a certain order. I'm going to start with the area to the left, so I'm not starting on problem number 1 here and get them to you in a random order. And we might skip around if we need to help these things make sense. Okay, we're kind of going to go in the same order we did in section 6.2. Okay, so this one says find the value of z such that 0.13 of the area lies to the left of z. So the big difference in this section is that we're given the area and we're asked to find the z value that matches it. That's backward from the rest of chapter 6. So here we're going to look at the values inside the table and figure out what value on the outside of the table matches. So it tells us that we've got an area of 0.13 to the left of z. Our tables give us the area to the left of the z values we look up, so we're just going to look for 0.13 in the tables. For some reason it gives us this 0 to z table. You can completely ignore it if you want to. You don't ever have to use it unless you just want to and you understand it. So here I'm going to be looking for an area of 0.13. I notice that that's kind of a small area, so I'm going to start on the negative side of the table. If these numbers are too small on this side, then I can go to the other one. And so you don't have to think too hard about which one to use. So I'm looking for an area of 0.13. Or since we've got 4 decimal places inside of our table, that would be like 0.1300. You can add the zeros on the end. So I'm going to look inside the table for 0.1300, or as close as I can get. So I'm just scanning down through these numbers. Right, these are too big down here. These are too small up here. I want the decimal and then a 1. Okay. And then I want my next digit to be a 3, so that starts right here. Okay, I've got 2 that are really close. I've got 0.1292 and 0.1314. Okay, and if it's not in there exactly, you want to get as close as you can get. It doesn't matter if it's bigger or smaller. You just want as close as you can get. So 0.1292 is a little bit closer. And you can think about all we'd have to do is add 8 10,000ths out here and we would be there. Here it's like 14 too big. So this one's a little bit closer. So that's going to be our answer. And that corresponds to a z of negative 1.13. And so negative 1.13 is our z value. Okay. So let's submit that one and try another one. So if it asks for the area to the left, you just get as close to that area as you can in the table and find the z that matches it. Again, I'm going to skip around. I want to do an area to the right next. So here's one. It says find the value of z such that 0.11 of the area lies to the right of z. Okay. So remember, our tables give us area to the left, so we have to use a little trick here. Let's think about what's going on. Okay, so the issue here is we want a z value. We've got some z on here, and we want the area to the right of that to be 0.11, or we could add 2 zeros, 0.1100. But our table gives us area to the left. So you got 2 things you can do. You can remember the whole thing is 1 and do 1 minus 0.11. And that'll tell us the area to the left. So 1 minus 0.11 gives us 0.89 or 0.8900. So you could look that number up and that would give us the answer. Or we can remember this thing is symmetric. So on the other side there's going to be a negative z that has the area we want to its left. So this will be 0.11 over here. And to me, I like not having to subtract, so what we can do is, even though this problem says we want the area to the right, we can just remember right means we got to take the opposite of the z we find. So I'm going to do this one just like the last one. I'm going to look for 0.11 inside of our tables, or as close as I can get. So it's got to be the decimal and then a 1. Okay. And then we want the next digit to be a 1, so here are 2 that are close. This one's 7 10,000ths away, this one's 12 10,000ths too big, so closest we can get is 0.1093. That gives us negative 1.23. But remember, we want the area to be to the right, so it's not going to be negative, we're going to take the opposite, so positive 1.23. So If it says area to the right, you can do it just like before. Just remember to change the sign on the Z. Okay. Let's find another. Okay, good. We've got an area between. On these, we have a little bit of work to do ahead of time. It's not terrible. We just have to do a little bit of scratch work ahead of time. So this says we want 0.9722 of our area to be between negative Z and Z. So let's sketch that. We want area 0.9722 to be in the middle of these two Z values. And so here's negative Z, here's Z, I forgot my negative. And in between there, we want 0.9722. Let me double check that to make sure that's right. 0.9722, yep, okay. So since we want an area of 0.9722 between these, we can figure out how much is here, how much is here. Right? So if we do 1 minus 0.9722, that'll tell us how much is in both of the tails together. Right? So 1 minus 0.9722 equals 0.0278. Okay, that's in two tails. But really what we need is we need to know like just how much is in one tail. So we could do 0.0278 divided by 2. Okay, I left my 8 off there. Okay, so 0.0278 divided by 2 tells us that there's going to be an area of 0.0139 in each tail. So that means over here on this left side, we've got an area of 0.0139. So what that's let us do is we've turned this into a left-tailed problem now. So that's one we already know how to do. We look inside the table for 0.0139, and that's going to give us the negative Z. And we just got to remember we want both on this one because it's worded a little tricky. Okay, it says find the value of Z. So our answer is always going to be positive on these in-between problems. Okay. So we're looking inside the table for 0.0139. Okay. Let's see what we find. 0.013639. Okay. So that gives us negative 2.20. But remember, just because this one's worded a little tricky, it says find the value of Z, not negative Z. For our answer, we're going to give the positive one, so 2.20. Okay. So those are area between. Okay, and once we can find those, then we can work problems like this. We've got a couple of these in here. So these are the trickiest ones in the section, but they're not too bad. It says, suppose GRE quantitative scores are normally distributed with a mean of 588, standard deviation of 154. The university plans to send letters of recognition to students whose scores are in the top 12%. What is the minimum score required for a letter of recognition? Round to the nearest whole number. Okay, so first we've got to figure out what Z value represents the top 12%. So we don't even care about the mean and the standard deviation right now. First, we're going to start with Z. We got to find our Z that matches the top 12%. So top 12%, that means that when we look at our distribution, we got our distribution of scores, there's some Z up here, and if it's in the top 12%, that means there's 12% of the area to its right, or 0.12 of the areas to its right. That's top 12%. Percentile means area to the left. Top percentage means that area is to the right. So now we can see this in line of the problems we've been doing. And we want to find the Z value that has an area of 0.1200 to its right. Since it's to the right problem, we can just look for this area and remember to take the opposite of the Z we find, right? We can look up the one on the other side a little easier. So we're going to look inside the table for 0.1200. Okay, so our first digit's a 1, and then we want a 2. Alright, so here we've got an issue where 0.1200 is exactly between two z's. And so in that case, we're exactly between, what is this, negative 1.18 and negative 1.17. Okay, so what we do there, and it only happens a few places on the table, but if the z we want is exactly between, remember we're going to change the sign, 1.17 and 1.18, then what we do is we add these two together and divide by 2, and we'll get a z value of 1.175. And we make sure I'm giving the right numbers here. That's right. So we made it positive because we're doing area to the right. And since it was exactly between these two, we add them together and divide by 2 to get our z. That only happens if the z you want is exactly between two areas. So here's our z. 1.175. But we're not finished because on this problem, it asks us to take the z and change it into a GRE test score, or in other words, change it into an x, a data value. So there's a formula. We want x, then we take z times sigma, our standard deviation, plus the mean. Okay. So here we want our GRE score. It's our z, 1.175. Got an extra 1 in there. Times the standard deviation. So it said the standard deviation was 154. And so times 154 plus the mean, means 588. And that will change our z-score into a GRE test score, into a database. So 1.175 times 154 plus 588. And so here we get 768.95. It said round to the nearest whole number. So that will be 769 would be our GRE score here. And so go back to our problem. What GRE score gets your letter of recognition? The top 12%. We figured out that is the GRE score of 769. That should be right there. And that is. And I think that covers all the types of problems we're going to look at. So this ACT score one's the same way. Same thing there. Let's make sure, let's look at the first couple, make sure we're good. Area to the right, we did that. Area to the right. In between, we did one of those. The left, so yeah, I think we're good. I think we covered all of them in between. What value of z divides a normal distribution in half? What value of z is in the middle? Okay, we got negative numbers on the left side, positive numbers on the right side, so what z value is in the middle? I'll leave that to you. All right, so if you have any other questions on any of these, let me know. And just send me an email or whatever you need to do, and I'll be glad to help.